So let's talk about this one that I asked you to try. So if I want to identify the acid-base pairs in this, I'm going to look and I'm going to say, what is this doing when it goes from this side of the equation over to this side? Well, it's losing a hydrogen ion. So if it loses a hydrogen ion, I'm going to identify it as an acid. If that's the acid, then the other one has to be the base. And so the base must be the one that takes on the extra hydrogen ion. So over here, I would name this the conjugate acid of the base. And then this would become the conjugate base of the acid. And the way you look at it is if you were to take it in the opposite direction, what happens? This would take on the hydrogen, making it base-like. This would lose that extra hydrogen, making it acid-like. So that's how we identify the conjugate acid-base pairs. So this is the acid, this is the conjugate base of the acid, this is the base, this is the conjugate acid of the base. Okay, so let's talk about the relative strengths of acids and bases. So there are different categories of acids and bases. They're strong and weak. And we'll talk a little bit as we go on about how to identify the weak acid. But your strong acids undergo complete 100% ionization. So HCl is going to show one arrow and go to 100% effectively, 100% dissociation, turn completely into a hydrogen ion and a chloride ion. Whereas a weak acid, like hydrofluoric acid, and it's weak due to its high electronegativity value, the high electronegativity of the fluoride, it wants to hold on to that hydrogen ion. And that's going to show a double arrow. So what that means is that when this is in solution, it's not all just hydrogen ions and fluoride ions. There's some molecular form of that acid. So that's what a weak acid does. It doesn't break up totally like the strong acid. Okay. So if you have a strong acid, so the stronger the acid, the weaker its conjugate. So in this case, if this is a strong acid, this would be the conjugate base of that acid. And so it would be very weak if this is a very strong acid. And then the same idea for the base. The stronger the base, the weaker its conjugate acid. That's just a handy little thing to remember. I think I posted a bunch of handy notes about acids and bases that would be good for you to just kind of print out and have near you when you're doing problems and taking a quiz or test. Strong acid completely transfers its hydrogen, and a weak acid only partially dissociates. So here I give another example where I show it in its reaction with water. And so here's what I'm saying. The hydrogen strong gives up its ion, its hydrogen ion, completely to the water, forming the hydronium ion and the chloride ion. And the weak acid, this is just a generic representation of a weak acid, such as something like acetic acid, in its reaction with water, producing the hydronium ion and the acetate ion. Sometimes when you were identifying a weak acid, because they're very large, complex organic molecules that typically make up the weak acids, we just use HA as kind of the generic form of the anion for the acid. Okay, I'm going to stop there.